Hey, welcome to the Azure SDK Community Stand-Up, where we bring you the latest updates, insights, and discussions from the world of the Azure development. In this episode, we will be diving into the Go side of the Azure SDKs. So today, we will be talking about Go fundamentals. Um, for today, we're gonna give you the overview. We will be talking about what's new in June, Azure SDK for Go fundamentals, and we have two guests, Richard Park and our very own Sandeep Sen, as usual every month, and we'll have time for Q&A. But before that, I always like to share a slide in which you can find the contact for the PMs on the Azure SDK team. We're always looking for feedback, or you can always reach us out to using the Twitter handle, and we're always happy to hear any feedback from the developer community. You have any concerns and how you're using our packages, we would like to hear from you. So keep this in mind. You can reach out to us during for Twitter, and if we don't know the answer, we can actually triage and send you to the right people. Let's see where we're going to talk today. Today, I wanted to talk a little bit about the initial stable releases for this month. We have a lot of releases for Azure SDK for Go, management libraries, Java, JavaScript, Python, and .NET. As you can see, there's a lot of New Relic observability, Cumula, New Relic, and voice services. But we also have initial beta releases, and we have a lot of AI content for .NET and Python, for Java and JavaScript, and Azure SDK for Go management libraries like Network, Cloud, and Self-Help and stuff like that. But I'll leave the slide at the end so you can take a quick look at that one. And then let's see, what are we going to be talking about today? We're going to be talking, let's see the overview. Today's topic is going to be the general structure and clients, authentication, and code patterns. But let me introduce Sandeep to the stream. Hey, Sandeep, how are you?
Hi, Hector. How are you?
I'm really excited to learn more about Go, and I know you're the PM for Go, right?
Yep, I am the PM for Go, and we have another guest today.
Yeah, you want to introduce Richard?
Yeah, so I want to introduce you to Richard, who is one of our lead developers for Go, and he is one of the authors of our Go SDKs. And why don't you introduce yourself, Richard?
Hi,
What's going
I'm
on?
Richard. Oh, sorry. I'm Richard Park. I work on the Go SDK, obviously. I've been on there for about 2 years, and I worked on the JavaScript SDK before that. But I finally found my true calling here. This is the right spot to be.
Quick question. What is that image you have on the back? Is that a squirrel, a chipmunk, or what is it?
What image?
You
Do you
have
see, Hector, do you see stuff again? Is it
I'm
happening?
looking, I'm seeing stuff. It's pretty early for me.
You'll be okay. You'll be okay. We'll get you help.
All right, Sandeep, you want to tell us a little bit about what we're going to be talking today?
So today's topics are focused on Go SDK as usual, but today we are going to focus specifically on the general structure of Go SDK, how it's structured in a repo, and how you can find it. Second most important part in general structure is clients. We use our clients to perform every action, what kind of clients you can use, and how to instantiate them and whatnot. Then we'll dive on to authentication. Of course, you need authentication to connect to any of these services. So we'll dive into that, and we'll close out with code patterns. Code patterns is like what kind of patterns we follow and what kind of patterns you can follow to use the Go SDK more optimally. And then we'll have time for Q&A. So why don't I directly jump into the general structure of our Go SDK? So Azure SDK for Go, as the name suggests, is our Go SDK, a set of client libraries to interact with Azure services. And it is essentially broken down into two blocks. First block is management plane, always starts with a prefix of ARM, which stands for Azure Resource Manager, and data plane, which starts with prefix of AZ for Azure. So in management plane, what you do is you can use that block of client libraries to create Azure resources. Let's say you want to create a VM. You can use ARM compute as the name suggests, to create a VM. Or if you want to create a storage blob, you can use ARM storage to create a storage blob. Whereas data, you can use uh, the resource you created. Let's say, for example, you created you created storage through ARM storage, and now you want to upload a blob into the storage. Then you'll use AZ blob, which is our data plane library. Or so essentially, you create and manage using ARM packages, management plane, and interact with the resources using data plane. And with that, I would like to pass it on to Richard to show more about how to find these libraries.
I'm actually not ready. Can you go on for a few more minutes? Real quick. No, I'm just joking. I got it. Okay. So let's talk a little bit about our SDK. One of the things that's important for the Azure SDK that we talk about daily is basically making sure that what we build makes sense to Go programmers. Like not just Azure Go programmers, but any Go programmer. If you've used the standard library or anything else that complies with the Go idioms, that it'll feel natural to use what we have. So in part of that, obviously, the biggest place, probably the most central place for most Go programmers is going to package Go dev and finding packages, looking at that documentation. Oh, sorry, Hector, looked like I had a question about that. It is what they do, no doubts. So if we go here, I'm actually going to look for AZ Blob, and this plays in a little bit with what Sandeep said earlier. We have ARM packages for management plane. AZ Blob is an Azure package, so it's a data plane package. And here's actually a good example of something that you want to look for as you go. We do have previously released Go libraries. Some of them are preview, for instance, this one. And so they're not going to be in our mono repo. And basically every new library that we publish will be inside of our Azure SDK for Go mono repo. That includes management plane, everything. And so when you're searching, make sure that you go and find the latest by actually going to the mono repo. So I'm going to go to AZ Blob now. Let's take a look at this structure. So sorry, you had a question?
Another thing is, if we go back for a second,
Sure.
to the page, anything which is not in the mono repo will not be stable, will not have a 1 or greater version. If you see the older one, which is not in the mono repo, is kind of preview. It's not stable yet.
Yeah, and in all likelihood, is probably not being worked on as much anymore. So that's something to keep in mind too. If you want to track the active development, it's happening in the mono repo. And if you didn't get it, the mono repo is the spot you want to be. Look at nothing else. Okay, so now looking at the AZ Blob documentation. So the README is basically the README we publish in GitHub. So if you wanted to, you could go to our actual repo, and in the root, you'll see the README, and it'll give you a kind of a linear style of like kind of a tutorial on how to use the library. It'll give you the key links, how to create stuff in the portal, like the reference documentation. If it's an HTTP API, it'll show you REST, all that kind of stuff. But it's not intended to be an in-depth reference. For that, you need to go to the documentation. And this is the auto-generated stuff using all the metadata that we add into the SDK. And the most important thing here is that beyond just the documentation for each function, you also get these examples. And these are meant to really kickstart like basically your application, because it means that you can just start right with the scenario that you care about. You don't have to go wade through everything like that. So if you want to get right to coding, this is the spot that you do it. I'm going to actually pick one of these to start with, just to kind of show you a little bit about why they're so great. So if you've ever used any other language, one of the problems they sometimes have is the snippet they give you is not complete. So it doesn't show you all the imports, and so sometimes you have to kind of cobble that together from several different snippets. In Go, we're able to provide these full file examples. And this is actually a complete Go program, including all the dependencies and stuff that you'll need to actually launch it. So let's go ahead and snag all of this. Okay. And I'm just in a code space here, so nothing special. And I have an empty folder with a little reminder file, ignore that. But I have an empty folder, and I'm just going to make a file. I'm just going to call it blobby.go and paste this in here. Okay. And we'll go through all this code in a minute. And when I go run it, I'll show you how to set up the rest of it so we can run it. But for now, let's just review what's in here just to see. All of our examples will try to help you not hard code a credential or some other sensitive information in your file by pulling from the environment. This is just, you can do whatever you want here. But in this case, we're pulling from the environment to grab the name of the storage account, which I'll put in here. After that, we're going to use the default Azure credentials. So if you've been hearing anything about passwordless, these kind of credential types, these are token credentials, are a big part of that. And the reason why they're great is because it means that you don't need to hard code like a connection string or a shared key anywhere in your environment. So you don't have to worry about rotation and all that. It's just an identity, and you get better tools for managing the identity than you would to manage the key. You don't have to build that yourself.
And where does it pick up this identity?
The default Azure credential. So if you look in the AZ identity package, there's a bunch of very targeted credentials. There's a CLI credential. There's a managed identity credential. There's a environment credential. All of these can pull from different sources. So if you're running on, like, say, a VM where you've associated a managed identity with it, it can pull from that local environment without any work on your part. If you're running on your machine, which I'm running on a code space, it can also pull from the credentials you've used to log into the Azure CLI. So essentially, you can use the same credential type without changes in both your production and also on your local machine, which is just great. If you've ever had to go through the experience of trying to figure this all out before, this completely solves it for you.
And I believe this is Azure Active Directory credential, ultimately.
Oh, yes. No, well, this particular one, because I'm pulling from my code space, is using CLI credential. But yeah, you have so many choices in different ones. And it is sometimes environment dependent. So some of them can pull from, say, like IntelliJ, if you're running in Java.
Right.
So once I have that credential, then I go and I have to find the appropriate way to instantiate the client. It's kind of, as Sandeep was saying, the client is the thing. You're just trying to find the client because that's how you can interact with everything in the package. In this case, I already have one, but let me show you a little trick. So if you're trying to figure out how to instantiate a client, you want to go to the package. Oh, hold on a minute. This is where I actually do need to run this. Okay, so first I need to establish that this is a module so that the Go language server will start up. So I'm just going to go mod init, and I just picked a name, and it could be anything, right? And then I'm going to run go mod tidy. And go mod tidy is just going to do this great little search through all my imports, everything that's in the folder, and then pick up everything that needs to be added and do it for me, generating a go.sum. It's kind of similar to a package
Why don't
log.
we go over the imports? Like, we have some standard library imports like OS and log and format. What about the Azure imports? Why don't we go through the last three imports?
Go through them? Sure.
Yeah. Like,
No, I refuse. So let's take a look at this. So this is actually a little utility package too, which I'll go through in a minute because it's actually below here. And it's one of the ones that we consistently, people kind of have a hard time finding it, probably because they don't expect that it would exist. But its existence here is just to make it easier to take like a constant string and turn it into a pointer. And things like that are just common when you're trying to interact with REST APIs where you have a potential for it to be nil. It's a pointer to a string and not just a string. And so 2 helps you with that just to make life easier. It's a convenience thing. You wouldn't have to use it, but you will want to use it because it'll make your life simpler. AZ Identity is that package I was mentioning before. It's the one that contains all the credential types. And if you're trying to figure out what credential types exist, the AZ Identity has excellent documentation. Go take a look at that README. They have graphics. They've got an explanation of every credential type in there. It'll really help you kind of get an idea also of how you can authenticate apps. It's just very educational. And then Blob. Oh, sorry, go ahead.
I was just saying, I would recommend users to spend new devs to Go SDK spend more time on AZ Identity at the start, because it's going to save you a lot of pain in the future. And I would strongly recommend you not to use connection string clients, although we have them, but please don't use them in production.
I mean, you can't use them in production, but trust me, there's a lot of benefits to not doing that. And the biggest ones are really just it's beyond just the initial connection. Thinking about the life cycle of your application over time, people leave, people come in, people do that. You don't want to turn this into a big management exercise for you. And that's a lot of what the whole token credential ecosystem gives you. It is an excellent package, my favorite. And then storage AZ Blob. So there's actually a little structure here that's kind of interesting. When we store the Go packages in our mono repo, we don't just put them at the root under their package name. We give them, there's a categorization system for everything that's in there. So when Key Vault comes out, it's underneath the security folder. AZ Blob is under storage. And then, for instance, if you're using Service Bus or Event Hubs, which are also GA, they go under messaging. Most of the time, it's pretty easy to find them, but it's just a little bit of a difference in the way that we structure our folders from other repos, where usually it's the package name that almost kind of leads the folder name. But in this case, I'm using AZ Blob. Okay. All right. Now we're going to make the client. And just before this, I was showing you, there's a little trick here, because if you go look at all the actual available symbols in a package, it can be a little bit overwhelming. And that's because it has all the types, the models, everything. And so we follow the standard Go convention of prefixing our creation functions that actually create kind of the main type with new. And in this case, you can see that we actually have several different overloads, basically, to create different kinds of clients with different credential types. Storage is really flexible, so there's quite a few. The rule basically is that if you're going to use a connection string or a shared key or something that is not a token credential, then it will have a name that kind of explains what it is. But if you're just using the normal token credential path, then it will be the new client, or potentially, if there are multiple clients, there'll be the name of it, like there'll be like a producer client or something like that in there. But this will always get kind of the simplified name. Okay, so now we've created a client. And once we create the client, then we can start to interact with it and do things that are actually useful, like creating a container. So if you're not familiar with storage, storage basically allows you to store just arbitrary blobs of data. And it's kind of hierarchical. So there's containers at the top. You create a container, and then you can put blobs inside the container. And so you kind of have to start with creating a container to basically do any work. So that's what we're doing here today. So here we have a create container call. And it takes a standard library context. So this is not this is not from us. This is actually part of the standard library. And it is one of the things that we find that people have trouble with sometimes understanding. So we'll explain it a little bit more, but I just want to point out this is not our object. This is coming from the standard library. Then we pass our null parameters, and then we get to this. So in the SDK, to allow for simple expandability without breaking everybody once we do it, we have options objects. Sometimes we call them an options bag. The options object will contain things that you don't actually need to pass. In other words, if I pass nil here, that would be perfectly acceptable. It would just choose whatever the service or client SDK defaults are. And if I fill it out, then of course I can put anything in there. And fields that I don't fill out will also just fall back to the defaults. So you really can go in there and just kind of touch the fields that you actually care about. And in this case, when we create it, we're actually adding just a little bit of metadata to the container to basically say hello in world. And if you look here, oh, sorry, go ahead, Sandeep.
I was just saying, like, if I don't pass that metadata also, can I pass an empty options bag?
You absolutely can. You mean if you want to do this?
Yeah.
Not only can you do that, people often do that. And then our architect gets disappointed that people don't think they could pass nil there. But it's understandable to be safe, but we have covered this case. So feel free to pass nil. You don't have to allocate an empty options object. You're perfectly fine. But if you were doing some code where it just kind of falls through, also absolutely fine. We'll cover you on that. It appears that I have lost the ability to actually resolve the to package. So I regret deleting that for you, Sandeep. There you go. Okay. All right. And here's actually a usage of to, right? To pointer, and we're using a constant, because otherwise I would have to define the variable, do this, right? And then pass the pointer here, because you can't take the address of a constant, you know. So we're just saving you that trouble. It's just a nice little convenience, syntactical convenience. Okay, so we're pretty much ready to run, I think. Hector or Sandeep, you got anything else you want to mention here about the sample before we get going?
After we run that, I want to talk to you about the context, because it's very important about timeouts and IO. So
you know what? Let's do that. Let's do that first. That's a good question. Okay. So earlier I kind of breezed over the context a bit. One thing that the context is useful. There's basically two uses for the context. One is you can cancel a context or allow it to time out. That allows you to regain control in your app earlier than waiting for the call to actually exit. The other reason is that there are a few spots in the SDK, which I won't go over today, where you can add a custom value or something like that that will allow the app to extract it and then maybe return you a custom result or something. But the most common use case is just simply to add something that's like a timeout, right? And that's just a good design principle for any resilient app. So I'm going to add this in here. I'm going to use context background. The difference between these two is context to do means that you're not actually sure where the parent context comes from. Passing an actual context or context background says that either you're kind of at the root or you don't care. But context to do also shows up in linters, so it's nice for just kind of stubbing something out and then coming back to it later and fixing it correctly. With context with timeout takes a timeout. So I'll just say a minute. We won't need a minute, but if it actually took a minute, that probably indicates that something's wrong, and exiting early is probably the right thing, right? You probably want to get out there faster than the socket timeout. And then we just pass the context. So this is basically the idiomatic usage. Create the context, defer the cancel, because you're allowed to cancel it multiple times, but you must make sure you cancel it to be clean, and then pass the context here.
And isn't there a trick also that anything which goes over the network takes a context for our Go SDK?
Yeah, we'll go over that too, but actually that's probably the simplest rule of thumb that you want to remember. If it takes the context, it's going to do I/O, which means that you're under the kind of the constraints that might happen with sockets and all that stuff. So you want to keep in mind that to make your app kind of robust, or at least to keep it within a reasonable time frame, adding these contexts is key. So if you see a function that does not take a context, for instance, like our clients, you know that it's not actually going to do any I/O. We always allow you to cancel any long waits. Okay. All right. Cool. Any other questions? Otherwise, I'm ready to fire this thing up.
I think fire
away. Okay. So I mentioned that we'd grab the stuff from the environment. This is not like an Azure SDK thing. It's just our samples. So let me go ahead and grab the name of the storage account from the portal. Okay. And then we're just going to go run the sample. This is that dead air that we were worried about, Sandeep. I can't make this go fast. Oh, there we go. Okay, cool. Whew. I had a story ready, but we'll save that. Okay, so now we've run the container. We've created a storage container. There's literally no data in the storage account. We haven't really done much, but I think we should call it a day after this. It's been a long day already, and it's only like 11. So, but let's take a look at what we actually did. So if we look in the storage account now, and just peek into the storage browser, and then hit refresh on this page. Okay, and then we just look at our blob containers. We can see we actually have a container, and there's nothing in it, right? But over time, you're going to have a lot of containers, because the whole point of it is organization, and just like on your computer, you got a lot of folders, you're going to do the same thing here. And so when you go and list these things, we also have another structure called a pager. And the pager is there to basically make it easy for you to go through paginated results. I'm going to pass nil because this is an options, it's a pointer, so I can pass nil and just ignore it, take the defaults, and I will get back a pager object. Now you're going to know something pretty critical again. I didn't have to pass a context here, and that's because creating the pager doesn't actually do any I/O. The I/O is going to come into the next part when I actually use it. So a pager, you just use.
Also, like we still follow the same kind of pattern, new and something pager, like new something client. So now you can do a new list blobs pager for blobs, paging through blobs.
Yep.
So
yes, exactly. So the pager
one.
items, the pager items will always be new something pager. So if you're kind of if you're looking from other languages where they typically just call it list containers or something like that, you're looking for the operation name here, and then the rest of it is basically the new pager. That's kind of the template. So we've created a pager. We still haven't done any I/O, but we're just going to go over this using basically looping until more returns false. And we're going to call next page. We're going to pass a context. I'm going to do to do here for a second. And then, so this is actually going to do I/O. It's going to return a result and an error, because it can actually fail because it's actually going over the network. And if the error is, actually we'll call handle error, since that's what we've been doing. Just for a note, handle error is not some special function. It is literally just in the example to do a fatal and die in the sample. You will want to replace that. Okay, now if we look at the response values here, we can actually iterate through all of the results in container items. Okay, and then just print it. Let's see here. %s, new line, and c dot name. Okay.
And also for blobs, it will be blob items. For something else, it will be XYZ items. Again, a pattern here.
So I'm going to comment this function out just for a second, and then we'll get back to another pattern. But for now, let's just run this and see if it lists the pages of or lists the containers. And it does, because we're that good. So now that we've been through all of this, you can kind of see the structure of the pager. It's pretty simple. And if you've ever used a scanner inside of the Go standard library. It's a really similar pattern. We try to use this pretty much everywhere for any object that's iterable. All right, go ahead.
And it's like a
this while I'm
standard pagination, right? So you can go for more and next and stop whatever you want to do. You can do it here.
Yep, you can do all your basically all your work happens in this for loop, and the continuation token ensures that you can come back and get the next page. So should make things pretty simple. If you just wanted to accumulate, that's a pretty easy pattern to write too. Okay, once again, the 2 package has disappeared. It's just too cool. That's the problem. I don't know why I can't find it, but it's my favorite module too. Okay. So I brought back our create container because I want to show you another piece, which is what you do when you want to get more information from an error. So this function is going to fail. In fact, let's just see it. And it's going to fail because the container actually already exists, right? So this is a pretty common thing that you'll see with HTTP APIs, right? When it actually fails, or when it already exists, you'll get back a status, usually 409, that says that the specified container is already there. And storage also does another thing where it returns some more specific codes to give you a little bit more granular information than just simply that the container already existed. Although in this case, obviously, we've already got this. So in Go, all errors are actually defined of type error. And error is just an interface. And that means that if you want to get more specific information, then you need to do basically what's kind of like a cast almost on an error. And they have a specific function to handle it because it's more complex than what I just said. And that's what we're going to use right now. So the HTTP stacks like AZ blob will return a response error. So we're just going to take a response error object here. Okay. And then we're going to call errors.as. There are 2 functions that you could use, but errors.as is the right one for our errors. We pass in the error, and then we pass in a pointer to the error that we have there. And then once we do that, now we can use the resp error because it'll be filled in by errors.as. And if you look in here, you can see that we have an error code. We have the raw HTTP response, which you may or may not need. Most of the time, we provide this information in a structured way. We have the HTTP status code, and then we just have the standard kind of functions we need for errors. In this case, what I actually want to check is the error code. And I already know what it is because it was printed out inside of the error message here. So I'm OK if the container already exists in this case. Usually, you're doing some sort of bootstrap logic for your app. You just want to check to see if it already exists, if it didn't create, so this is how you kind of do a create if not exist. So if the container already
What if I don't know the string? How do I go about if I don't know the string?
It's unfortunately impossible at that point. We have not solved that problem. No, we solved it. We've solved it. I'll show you in a minute. This is actually, I'm just doing this for a quick little example, and I'll show you how to do it so that you don't have to do what nobody wants to do, which is hard code a string out of nowhere that you don't know why it exists. But I just want to do this real quick to show you kind of how it works. So we can go now and look at the error code, and if it does, then I'm just going to print, everything's fine. Container already exists, right? Because life is all right. And then if not, then I actually want to say, hey, if the error is not nil, so we'll do an else if here. There are nicer ways to structure this, but we're just sticking with the simple. And then here, I'm not OK with it. And oh boy, it's getting slow. I can't handle that 4K, I guess. All right. And then if it's anything else, then we'll handle it here. So basically, in both cases, if it's anything but container already exists, we're going to bomb out. Okay, run it again. And well, Hector, this is one of those endearing moments where I made a mistake. Let's just take a look here. So if errors as resp error.error code equals container exist, everything's fine. Otherwise, handle error. What did I? Oh, sorry, we already had this here.
Yeah.
Jeez. I think they pay me for this job, Hector.
It happens to the best of us.
Yeah, also to me. All right, so let's run this real quick. All right, everything's fine. The container exists. Exactly what we expected to happen. Perfect, just like we did in rehearsal. All right, so now that I've done that, let's address the question that Sandeep had, which he would have put into my PR and said, where is this hard-coded constant coming from? Rather than do all of this work, AZ Blob actually has a great package to handle this already. So I don't even need to do this. I can actually just use AZ Blob's blob error package. And this will show up in the README, by the way, if you're just trying to figure out how to find it. I'm saving you the trouble right now. And then you can call has code, pass it the error, right? We can actually get rid of all of this boilerplate. And then we just go to blob error dot, and then container already exists, right? And now if we do that, we can just print everything's fine, right? And that's it, right? So now this is the same program, just much less boilerplate. We run it, and it works.
And these error packages are available for all our libraries, right?
Yes, their structure might be a little bit different depending. So Blob is a little bit unique and interesting too, because it represents a somewhat new design where we have a simplified set of clients at the root of the package. Those are the ones that I've been using this time. And then there are more detailed packages for each area, blobs, page blobs, all that stuff underneath. So there's a shared blob error package, but wherever the errors come from, it'll be documented basically in the package itself. But all of the packages will either export response errors or a custom error, and then that will be documented inside of the package.
So if I'm a dev using the package, I just go in the package, find the README or a reference, look for the error package, and use that package.
Yeah, I didn't show it here, but if you look, it's often also in the documentation comment for the function to tell you that as well. All right, I believe that's all I have, unless anybody wants to see something else.
I want to know about logs. How do we log? Like, this is all fair and good, but I want more logs.
On the rare occasion when there is a bug or when you want to see more information, you can actually turn on diagnostic logging. We've always got this available. There's a troubleshooting and diagnostic section at the end of our READMEs that show you how to turn it on. There's two ways to do it. One way is you can do it programmatically. And this is something you can use if you want to be very granular about what you enable. Like for instance, this is the AZ Event Hubs package. If you want to just see Event Hubs events, then you can actually turn them on selectively. The other way is
what did I do? I imported a AZ core log package.
Just like the two package, we have some utility packages underneath AZ core, and one of them is log. And log allows you to set your own listener if you want, so you can redirect the output. You don't have to just go to the console. You can send it out to App Insights or whatever your tracing system is. And then it also lets you pick the events if you'd like to filter it, because every package, the core packages, all of our HTTP information, authentication, all that stuff, all prints information to the logging system. And that can be a little bit large if what you're actually trying to do is just look at, say, for instance, AMQP connection issues. So this is definitely one way you can do it. If you do, you got to do it at the start of your app. It's not a concurrent safe API like other APIs. So you do this once and you do it at the start. Now the other option is, let's say sorry, go ahead, Cindy.
No, I just said okay.
Yeah, you accepted it. It's a good answer, I thought. But let's say you didn't want to modify the app. So you've already deployed it, you've already built it, and all you want to do is enable logging. Then you can actually just enable an environment variable. So if we go back to here, this line's getting a little long, but we'll be okay with that. And I can just define Azure SDK go logging equals all. And now when I run it, it's going to give a lot more information. In fact, let me just expand this out so you can get the full experience. Okay, now you can see everything that's happening, right? So, and we redact some of the sensitive stuff so you don't accidentally log like your actual OAuth token or something like that. But we do log a lot of the common stuff that you probably want to care about, like the headers and things like that, the URLs that we use, and then the error codes that come back, including the error responses if there is any. This is a useful thing to use when you're if you want to send a diagnostic log to us, like to file an issue, then we'll often use these logs to figure out what happened. It can also give you a little bit of viewing or a little bit of information about stuff that you don't normally see. For instance, if you're having network connection issues and we do retries underneath, you're not going to see that externally because eventually the retry might succeed. And so this is probably the only way that you can really kind of take a look at that. So it might be useful every once in a while. Turn it on, make sure everything's going the way you actually expect, and then just kind of get more info that way. This is also a good way if you want to see how the authentication works. I mentioned earlier on.
It just showed the authentication that it grabbed Azure CLI credential. Yeah, I think if you scroll down, it'll show you.
Yep. If you go through in the default Azure credential, we try a bunch of credentials basically in parallel. And so it picks one that succeeds. So basically that's the one that wins. And so here you can see that we actually did try to reach out to that internal metadata endpoint that exists on managed VMs, and it failed. So you can also use this if you wanted to figure out, for instance, why the credential type you wanted to use didn't actually work. It could be helpful for certain areas like that as well. So it does look a little alarming, but really this is everything working as intended.
Is there other log levels apart from all?
There are none. So in the Go SDK, we don't have different log levels. We do allow you to do component logs where you can actually say this particular area I want to get logging for, but we don't have kind of like other systems where you have like a warning and an error and a debug and all that stuff. We try to be very, very concise with our logging. So if we log it, we think it's useful, and if we don't think it's really useful all the time, we don't.
Yeah. I think this wraps up everything you need to know to start working on Azure SDK for Go. And like to recap, there are clients, there is credentials, patterns for pagers, and patterns for error handling. And all of these can be found in our docs or our readmes.
I like the fact that it's very idiomatic, like you mentioned at the beginning, right? Like you don't have to be an Azure developer to understand what's happening.
This is my favorite thing, and I wish we don't. So we don't publicize these. But if you ever, we have these architecture board meetings, and every language has a couple of architects that feel very strongly like they bleed that language, like that language's syntax and idiom. So when we go in, it's an important thing that every architect wanders in there and is not just trying to create the C# version of their API. And it's not because C# bad, but those idioms don't apply to everything. Every language has its strengths, different standard libraries, different patterns. And so it is a really cool sight to see when people come in and they're like, no, that won't work in Python, or that's not how we do it in Go. And we come together for the concepts and for the discussion, but everybody comes up with the design. And you will see that on occasion when you use a library, you'll see that we went a different way than what, for instance, happened in other languages like JavaScript or Python, because we really wanted to make sure that the experience felt like a Go library. So that does happen quite often.
I like that it's not just an emulator, right, of another language. We're just doing that. I just wanted to mention this link for the Azure SDK Go, but we'll go over it in the contact at the end. But Sandeep, you want to take it from here?
There are a couple of things I want to go through, which is stable packages. As alluded to earlier, always go to our monorepo for stable packages. Any package which is not in our monorepo is either deprecated or will be deprecated pretty soon for Azure for Go. And pretty much you can look at it, they're not actively developed on. And if you find a package like that which is not actively developed on, I don't think you should use it on your production again. Or always reach out to us on GitHub and or Twitter and ask us, hey, I want this package, where is it? And we'll help you out.
A key point to mention there too is that for older libraries, on occasion there'll be a feature there that we did not bring over to the newer library. And if we miss something that you're using, then let us know. We don't have an all-seeing eye, so sometimes we miss a scenario that maybe we didn't understand or didn't think was actually useful anymore. So please, we take feedback. We've got all sorts of stuff in our issues where people are just asking about particular features or wondering if something will happen. We always respond.
In case you find that thing missing or something, go to this URL, which is our link to GitHub repo, create an issue. Create an issue and tag us and we'll respond. So the good news is all management plane packages are stable. Any resource or any service which we have in Azure is already available as a stable management plane package. You can use it and create resources. For data plane though, we are very selective starting. So we have these 5 packages which are released, and we have Key Vault and App Config in the pipeline. And in a couple of months, you'll also see our first beta version of OpenAI for Go, Azure OpenAI for Go library. So stay tuned for that.
Speaking of staying tuned, can we let them know how to get there? Can we move to the latest slide?
Yes.
So there's a lot of ways that you can reach out to us. Like Sandeep mentioned, you can always go here to the repo directly and, submit some issues or get involved that way. This one would take you to the releases page, But also, I would highly recommend to go into your the ak.ms AC SDK releases, so you know all of the other packages. You don't only work in Go, I'm sure, and you want to know what other languages are doing or what the whole team is doing. We're always looking for feedback and how to and people to contribute with us, and you can always go to the GitHub page. Follow us on Twitter. We do a lot of announcements in there, and I will strongly recommend to follow the blog, because I'm gonna throw Richard under the bus right now. But in the next couple of weeks, we will be submitting a blog post with this topic and getting a little bit more information about what the Go world is doing in the Azure SDK team. You can always share on Stack Overflow. Just check out Stack Overflow, and yeah, just reach out to us. Just as a teaser, next month, today I felt a little bit out of place because Go is not my language, but I learned a lot in how you guys do things. So next month I have Matthew Podesaki, and he's from my team in JavaScript and TypeScript. So we're gonna be talking a lot about some of the OpenAI, Azure OpenAI advances that we're doing with the JavaScript world. So stay tuned for that one. Please follow us on Twitter or subscribe to this channel, and we'll be there. Something else that you would like to say, Richard?
Yeah.
Last
Advice to Go devs before we leave.
last advice: you should use the SDK. And I do want to publicly apologize, Sandeep, for yelling at you yesterday. That was unnecessary. Way more than you should have.